Thank you very much indeed, Art, and thank you, John, for having me here, and thank you indeed, honored guests, ladies and gentlemen, for coming out to this cold day to hear about cold fusion and other developments on the frontiers of science, chemistry, and physics, and perhaps other areas. Since we have a rather small group, I would say this is an opportunity to have a very informal presentation. I have a lot of material. Actually, it's almost impossible to cover the subject thoroughly in so brief a time as 3 hours. There's a lot to talk about. We'll get into it right away. But I would ask you, if you want to keep up with this field after you've done your own research, your own due diligence in determining that I know wherever I speak and I'm telling the truth and I'm giving you truthful facts, and that there is an enormous field here to explore and get active in. The way to stay in touch with this is to perhaps subscribe for this very nominal price of $29.95. This is a labor of love. We do not get salaries for this. We who work on this, we will someday, we hope, when we're no longer printing 3,000 copies, but we're printing hundreds of thousands. And you'll be hearing a lot about the story that's on the cover of our second issue. We have 4 issues out now. We have issue number 4 here available. This is the famous clean energy technology Patterson process that has the first United States patent and is now entering commercialization even as we speak. We'll be talking about the recent demonstration that was conducted in Anaheim, California. All right, and the other thing, of course, for background is to read Fire from Ice, which is the cold fusion story up to 1991. Let me just tell you the outline of the day here. Just have a brief introduction, little brief history, just lead on into the classes of evidence that we have. Then let's get involved in talking about this demonstration that occurred both at a hot fusion meeting recently in Illinois and at PowerGen 95 in California, which is the largest fossil fuel and nuclear power generation conference in the Americas. Okay, a very dramatic breakthrough, and I will tell you the bottom line on this device that was demonstrated there in a number of forms. Over a kilowatt of thermal output power was demonstrated. In one case, they did it for 5 hours. Doesn't mean that it wouldn't go on indefinitely. They just did it for 5 hours. They were showing it to various industrialists. But the input power to that cell was only 1.4 watts. The output power was about 1.34 kilowatts. Very hard to miss a power ratio like that. And that's just the beginning, my friends. That is essentially an almost ready-to-go commercial product. All right. We can't avoid speaking about this regrettable affair, which is, I affectionately called Heavy Watergate, which is the scandal of attack, disinformation, etc., outright scientific misconduct on the part of certain universities against cold fusion. We'll proceed on to something else, which is what I would call the new energy part. There are other apparent energy sources in matter and in machines. I say apparent. I haven't signed on to all of these. This I have. There are certain cavitation devices in water, such as the Hydrodynamics Incorporated hydrosonic pump of Rome, Georgia, that appears to be absolutely validated at this point as a multi-kilowatt excess energy producer. Not with a high power ratio, but let's talk about that later. And then this unbelievable new direction of motors, magnetic motors that appear to produce more energy out than in, which is a absolutely shocking and heretical claim of the highest order, to say the least. The only problem is that certain major Japanese corporations are deeply involved with that right now. One of them has gotten the United States patent issued on it already, and there are more to come. And I personally feel that that field is real, but I am open. I am open to finding out why it is not real, just as I was open to finding out why cold fusion was not real during the first year. And then for dessert, after 4 o'clock, we can watch this 50-minute film, which was done by the Canadian Broadcasting Corporation and the British Broadcasting Corporation, broadcast all over Europe, all over Canada, but in effect banned in the United States. 50 television networks and stations were given Federal Express this wonderful film, and none of them chose to broadcast it to this day. The opportunity is there. They can immediately broadcast it if they wish. It shows cold fusion up to 1994, but they have chosen not to broadcast it. All right, and on we go. Well, what are we talking about here? We are talking about two oceans of energy, possibly. Water, which is around the planet, effectively infinitely available, especially since the amount of hydrogen required to run many of these devices may be either nearly nil or literally nil. And the ocean of space, which is vacuum, which may yet contain the source of energy. There are certain people, such as Dr. Hal Puthoff at the Earth Tech International, who believes that zero-point fluctuations in space-time are responsible for this energy capture, and that cold fusion experiments are merely the transducer of this vacuum energy. That remains to be seen. I wouldn't be here had it not been for where I was at the time of the cold fusion announcement on March 23rd, 1989. I wrote this book on cold fusion, Fire from Ice, and it's the source of why I'm here at all. I saw the story come out. I watched it with great fascination and shock, and I think I have some good background on the multi-dimensional aspects of this story. There are other issues. This was used from a previous discussion. There's no evening session. I have to get back to New Hampshire. But there are issues that I'll blend throughout this entire presentation. Government policy, congressional and executive action, research funding at national labs. These are major issues that should be on the table right now. I urge any of you who have any contact with your political leaders to do whatever you can do as citizens to make them aware of it. At the very least, write your congressman a letter. Point out the issues, buy him a subscription, whatever. National security issues, military issues, obviously economic issues, which are part of our national security. These are the highest, this subject, in my own opinion, is right now the hottest and most important national security issue. It is not Bosnia, it is not anything else, it is this. Because this is going to free us completely from, in my opinion, oil from abroad. It will eliminate air pollution, it will do many other things. It will be a vast economic impact starting almost immediately. Geopolitical consequences are obviously involved here. The environmental impact is astonishing. There are social issues, taxation issues. What you find out when you study this whole episode of cold fusion and the related heresies to it, you find out that you learn a lot about the process of science. You learn a lot about the media coverage of scientific controversies, or lack thereof, lack of coverage, and research ethics, and the reporting of scientific results, and the general decorum of science, which turns out to be not very good at all when something is different. The scientific establishment does not like things that don't fit into its picture. At best, they usually give tongue-in-cheek little jokes about such things as cold fusion, crop circles, UFOs. But I think they've met their match with cold fusion, because cold fusion is something that can be completely reproduced. It will be commercially implemented, and as a result of that, the scientific establishment is in for the greatest shock to its foundation, possibly in history. We'll see. Galileo was a pretty good example, but they didn't have TV coverage then. Now we're going to dig up the TV tapes and the words and the printed words and the outrageous behavior of the scientific establishment over the last 7 years. We'll put it all together, and the people of the United States and the world can see what happened. Well, it's real after all. Nature, Science, MIT Plasma Fusion Center, Princeton Plasma Physics Lab, American Physical Society, Caltech, Harwell, England, Department of Energy, etc., etc. They were all wrong. About what? Cold fusion is an unknown phenomenon, or phenomena. Still is. We don't know what causes it. It's just a catch-all name. It was thought to be a nuclear process. Some people still think it is. Gives rise to excess power and nuclear effects, not always nuclear effects, in metals in contact with liquid and gas media that contain hydrogen and its isotopes. It's a generic catch-all term. When I say cold fusion, I don't mean literally fusion. There is substantial excess power that has been confirmed in these experiments, such as when you put 1.4 watts in and you get out over a kilowatt. And when you add up that energy, the magnitude is far beyond chemical explanation. Not only is it far beyond chemical explanation, my friends, but if it were chemical, in the classical sense chemical, you would expect to find ash there of a fairly substantial order when you're getting kilowatts of excess power out of a small volume of material. That ash does not exist, as far as we know. Certain theories which involve shrinking hydrogen atoms, yes, those may explain it. May. Not necessarily, may. However, as far as conventional mistakes, such as gross chemistry that is there that could explain this, no way. There is no known energy storage mechanism that could store energy like this. If there were, it would be wonderful. But it doesn't exist, as far as we know. Nuclear products are confirmed, such as tritium, neutrons, charged particles, helium-4, and heavy element transmutations. One set of such transmutations in a Pons-Fleischmann cell has been confirmed by one of the worst skeptics in the field. He refused to print this data, so we printed it for him. Okay? We published his data. It was owned by the Electric Power Research Institute, which you pay taxes for. We published it. No commonly accepted physical explanation. I'm very interested in theory, by the way, but as far as my ability to deal with theoretical understanding of this, I can tell you why people say it shouldn't happen and why they say it should happen, but in general, this isn't as important as commercializing it and getting people to accept it. As I was telling you, there's overwhelming rejection by the scientific establishment, but nonetheless, there is an immense technological and scientific revolution in process right now. Home heating systems and home electric generation will be done. Years without refueling, if ever, and with only inexpensive materials. There will be cold fusion-powered steam electric automobiles. If there's an exhaust at all, possibly won't be an exhaust, just heat, exhaust, waste heat. I imagine, by the way, that the first cold fusion-powered car, you'll see if I'm right, a small one, small vehicle, go-kart type, maybe a little bigger, will occur next year. I know the person who's trying to build one. We'll see a tape of him here today. Central station electric power generation is going to fade away, in my opinion. There will be zero, people will generate electricity in their homes. There will be zero CO2 emissions, and it will be extremely safe. As far as space propulsion, the easiest route to apply this to immediately, and I'm sure it will be done, is, I said fusion. What I mean is cold fusion, electric ion engines. Ion engines are ready to go for deep space flight to the planets and beyond. All you need is an electric power source. Nuclear fission doesn't fly, either politically or mass-wise or problem-wise, but cold fusion reactors in space, which I'm sure we'll see in the next few years, will power ion engines. High thrust-to-weight rockets, I have very little doubt these will occur also, so we may have launch off the Earth's surface with cold fusion engines. There are certain processes that I'm not even at liberty to talk about at this point that I have been witness to. I am not absolutely sure myself that they are over unity. We have to do more checking first, but they appear to be very high temperature. If they are correct, this is going to happen. Okay? Launch mass will go way down. Isotope production via metal lattice, neutron transfer, or whatever is happening to create these isotopes. We will have isotopes, radioactive and non-radioactive, in any quantities we want. Desalination and enhanced agriculture. For example, in a cold climate, you could have heated buildings to do agriculture. Why not have agriculture year-round in Siberia? Infinite possibilities, and of course, starships, particularly if the energy turns out to be 0 point, or some space energy of some kind. Two latest developments here, very, very nice for the field. The original Pons-Fleischmann patent has been granted, or should I say the announcement that they are going to grant it has occurred by the European Economic Community Patent Office. ENECO of Salt Lake City owns the worldwide rights. The other thing is Congressman Walker from Pennsylvania, who's in the district of Dr. Randall Mills, who's involved in the so-called hydrino theory of coal fusion and experiments and commercialization at Hydrocatalysis Power Corporation. He says in Popular Science, October 95, he says that one of the first bills to come out of my committee was the Hydrogen Fuel Act. Hydrogen seems to be a potential energy source with benign environmental properties. I'm also personally interested in the so-called coal fusion area. It's not fusion, obviously, but there's something that's producing additional heat, and it's been found in laboratory after laboratory. This man is the head of the Science Committee in the United States House of Representatives. Please write to him. No one at this point can explain it, he says. The hydrogen bill sets aside some monies to go into highly innovative research such as this. Nice. But of course there are those who don't believe, and here's one of them. This is what a coal fusion skeptic looks like. He's got a snarl, and he's very angry that this lecture is occurring today. I understand some flyers were put up in some of the physics departments here and there, and many of them were taken down. That's fine. I've had the same experience at MIT. It's universal. But we know what's going to happen to these folks. Here's a cartoon by Sidney Harris of the general problem in coal fusion. It is a problem. There's no doubt about it. This is a shocking, shocking paradigm shift. I'm on the verge of a major breakthrough, but I'm also at that point where chemistry leaves off and physics begins, so I'll have to stop the whole thing. Fortunately, Pons and Fleischmann didn't stop, nor the rest of us. This is a multidimensional story. It's astounding and revolutionary, many lessons. A too strange to be true human drama that proves that scientists are imperfect human beings. They are not objective automatons. They are people with emotions. And when you hit them in their emotional solar plexus with something that cuts at the very core of what they think their beliefs should be, they react in a very violent way. They are not objective by any stretch of the imagination. In fact, I wouldn't necessarily consider myself objective. I try to be. But I don't have much of a vested interest. A lot of us in this coal fusion field have suffered rather badly, okay? And so we didn't get $200,000 a year salaries, for example, for working on hot fusion. We have a belief that we were right about the evidence, and we pursued it. That's all we have, okay? Whether we ever get paid for it remains to be seen. I think we will. Revolutionary changes are on the way. Energy production, transportation, agriculture, the whole thing. I've gone through it already on that. Okay. There are many coal fusion processes, by the way. We're not just talking about the original Pons-Fleischmann. We're talking about, of course, the original one, which is very tough. Our two heroes took the toughest one. That's the system it started with. You know, heavy water, palladium, and platinum electrodes. Then there came the molten salt process of Liebert and Liao in Hawaii. You can look into that. High temperature process. Randall Mills with this unbelievable turning point in '91 that was announced. I understand we have a Randall Mills expert in the audience. Light water in potassium carbonate with nickel electrodes producing heat. Verified over and over again by numerous laboratories, especially Thermocore in Lancaster, Pennsylvania. Glow discharge in either light or heavy hydrogen gas. Piantelli in Italy is especially good in this now, and in the latest issue of our magazine we have the whole Piantelli patent here. I was in Siena and I saw this apparatus. I believe that he's absolutely got it. They've worked on it for years. They're absolutely sure of the excess heat. It is stupendous. And Fiat, by the way, is behind his research. They are supporting his research. Ultrasonic activation by Equest Sciences Corporation. Ultrasonic melting of palladium underwater instantly or very quickly upon activation under heavy water. Ceramic proton conductors. Dr. Mizuno of Hokkaido University in Japan has this very hot process of solid electrolyte, it's called. Protons being conducted through solid materials, various rare earths and other materials that do indeed seem to produce, not seem, do produce, tremendous excess heat. But also, he has seen isotope shifts now of a startling character. Magnetic, well, we talked about this, nickel and hydrogen, that's sort of like this. This was glow discharge. I shouldn't have stepped. Glow discharge. Jacques Dufour of Shell Research in France does this. Others do it. Piantelli is just hydrogen on nickel, triggered with magnetic stimulation, current pulses, and so forth. Turbulent activation, like the hydrosonic pump, where you just have turbulence in ordinary water. Intense turbulence and cavitation producing excess power. I wouldn't have believed it myself. It sounds crazy that a rotary device, turbulent, highly turbulent, within a shell, two steel shells, could produce more power in. But I physically was down there at their installation. I measured for my own sake to find out whether this was real. As far as I'm concerned, the number of BTUs we were getting into that 55-gallon barrel of 350 pounds of water, the steam condensed into it, was more energy already than the electric input. Not even taking into account the inefficiency of the electric motor and the other heat losses. It's, as far as I'm concerned, case closed that the hydrosonic pump is an over-unity cavitation device producing excess energy. It doesn't produce enough, unfortunately, to self-sustain, but who knows if it were developed, what would happen with it. Well, here's the context of the whole thing. The world population is increasing, either to 10 billion or 15, somewhere in there. We're here, struggling along. Fossil fuels are here. Sure, we could burn them, but they're obviously going bye-bye. Fission has got troubles. Sure, we could do a lot of things here. This is produced by a hot fusion man at Lawrence Livermore. Yes, hot fusion had the right idea. There is a problem in energy. We need something radically different. And they thought it was going to be hot fusion, which would give us reactors by the year 2050 to help this gap between the fossil fuels and the fission fuels. But now it's here. It's arrived. It arrived in 1989. And now it's here to be commercialized. This gap will not exist. We will have as much energy as we want. Infinite amount. There is no energy gap. End of the energy crisis. As soon as this is commercialized, of course. So we can have fun burning fossil fuels for, a couple more decades. No big deal. Maybe we'll bottle this stuff and put it on as, souvenirs of the bad age or the bad era or something. Anyway, the hot fusion people wanted to do it a different way. Very heroic effort, unfortunately going to be coming to an end. Is in the process of coming to end. I believe this is the TFTR at Princeton, the tokamak there, multi-$100 million program. Fusion had been getting about $340 million a year. This is the Nova laser system to bombard little pellets and create little mini hydrogen bomb stars. But they never could quite get their act together. Hot fusion is always the energy of the future and always will be, as they say. But now it is being truncated, even without cold fusion, by the Congress down to 240 million, and it will soon be abandoned completely. I have little doubt about that. Next year, I think, will be the last year that there's a tokamak program. Here's Pons and Fleischmann in their lab, just to show you the heroes who announced this amazing discovery on March 23rd, 89. They claimed this excess heat, they claimed neutrons, they claimed tritium. It turned out that their neutrons were improperly measured, no question about that. It turned out that they didn't really have good evidence for tritium. So what? It turned out that others have gotten tritium in spades in certain cold fusion experiments. This tritium should not exist. Radioactive form of hydrogen, can't generate radioactivity from non-radioactivity, so we thought. But many people have done it now. And they've been greatly assailed. Dr. Pons, in fact, both of them are working for Toyota in France now at the IMRA Japan laboratory. And Dr. Pons has decided to give up his American citizenship because he feels very badly about what happened to him. And frankly, I don't blame him, but I wouldn't give up my citizenship. May 8th, 1989, it was all the rage. The media went wild over this story and then somehow disappeared, as they usually do when they lack interest in something. And they were told by the experts that this was nonsense anyway, so they decided not to cover it anymore for the most part. And so they went away, disappeared. It was on the cover of Newsweek. Maybe it'll come back again soon. Who knows? It was on the cover of Time. Okay. And it was on the cover of Business Week. All on May 8th, 1989. It deserves to come back, don't you think? This is what their little cell looked like. That's an actual cross-sectional view of what the cell was with the palladium cathode and the helical anode and various temperature probes. This was a Dewar flask. And the whole issue back then, it's all calorimetry. That's all it is. Is there more heat coming out or not? Is there more heat coming out or not? And yes, when the power levels were very low, it was a question. They might have made a mistake. The recombination of the oxygen and hydrogen might have explained it away. But not when you're dealing with, as we are today, with a kilowatt over 1 in. It doesn't, recombination is no issue. Besides, closed cells have been run. The recombination of the gases, of the electrolysis gases, is no issue at all any longer. This was the diagram that I put in Fire from Ice, just to show you the Dewar setup for calorimetry. It's just measuring the temperature difference between here and there and determining whether it makes sense. Given the power put in, you can do a calibration using a resistance heater. Calibrations were done. Calibrations have been done over and over again. By the way, the bottom line is the following. Here's a fundamental law of the cold fusion story. No scientific experiment will convince the critics. No scientific experiment will the goalposts keep moving. First they said they wanted closed cells. They gave them closed cells. They wanted controls, light water versus, they got that, okay? By the way, whenever you hear critics talking today, they'll say, oh yeah, it occurs in light water too. But they forget, light water with nickel, not light water with palladium. You don't get substantial excess heat when you have light water with palladium, but you do get it with nickel. So the critics they're not thinking properly. They're quite frankly disorganized and virtually driven insane with their anger against this field. The goalposts keep moving. You give them better and better tritium results. They don't care. You give them better and better helium-4 results, and there are helium-4 results that are extremely good. They don't care. The only thing that will turn this around are commercial products and very high power levels. That's beginning to happen right now. The essence of the story was that it got to be called cold fusion because it was deuterium in a palladium lattice. And the question was, how does the paradigm of the hot fusion, which is shown here, fit into the cold fusion? Let's see. If you have a deuterium and a deuterium nuclei colliding and fusing in a hot fusion reaction at millions of degrees centigrade, Kelvin, you would normally expect 50% to be in the form of reaction products, helium-3, very rare isotope, and a neutron. 50% in radioactive tritium and a proton. So 50-50, a very small fraction in helium-4 plus a deadly gamma ray. Several tens of MeV, million electron volt. This would be, if real fusion were occurring, if standard classical hot fusion were occurring in significant amounts, certainly to the fraction watt level in a Pons-Fleischmann cell, Pons and Fleischmann should be dead. So, the opponent said, since Pons and Fleischmann are not dead, therefore their experiment must be wrong. There's a mistake someplace. Arguing in a very rather absurd way that there could be nothing new in nature. It had to work like hot fusion in a plasma. Therefore, it's wrong. Okay. Well, we know they're not dead. It's also called the dead graduate student problem. They are not dead. The graduate students are very much alive. This is what Princeton and MIT and others building the practical hot fusion reactors would like to do. They would like to take deuterium, which is in seawater, part of heavy water, and react it with tritium. They've done this already in reactor tests up there at Princeton, and create helium-4 plus a neutron. And this neutron that goes out very fast is the method that hot fusion would use to get heat. The hot neutron, the fast-moving neutron, would be captured in a molten lithium jacket of some sort, going through the steel wall, and that would be your wonderful heat. And in the year 2050, they might actually produce this monster. Professor Lawrence Litsky of MIT in nuclear engineering, who walked out of the Plasma Fusion Center in 1983 and wrote a major controversial front-page technology review story saying even if we could build these, and he thought we could, no one would want them. And that's true. We could conceivably build a hot fusion reactor in the future, but no one would want it. It would be commercially totally non-viable. Most people know that, but they still go on taking the money year after year. That's the way things work in the government, and ignoring cold fusion entirely. However, part of the cold fusion story ended up down this path. They said, okay, we'll give it to you that maybe something strange happens in the solid lattice, that maybe you don't get these two pathways, or you get some of this, you get some tritium sometime and little helium-3, but dominantly it might go into helium-4, and the gamma ray may get somehow absorbed as vibrations in the lattice somehow. But not too many people were able to see helium-4. If you did, it's never been particularly commensurate with the excess heat. That's the problem. Few people have seen it, but it doesn't seem to be commensurate. So, I think that it's completely open. We don't know what's going on. We just don't know. So if we don't know, let's just get the power up higher and higher, as it is now, to the point where some of these cells are so powerful, you run them continuously, and if there are nuclear products, if it is an unknown form of nuclear reaction, you should be able to see the products. If you don't see the products, well, sorry to say, folks, got to rewrite some physics at that point, or at least think about zero-point energy, because you can't throw away the experiments in favor of theory. You can't. You can try, but it doesn't work. You can't fool Mother Nature. Simple. During the cold fusion controversy, there was always this, because one half day after the Pons-Fleischmann announcement, ironically, the Exxon Valdez hit Bly Reef, dumping 10 million gallons of crude oil into Prince William Sound, and there we have our buzzard or condors, whatever they are, and sea lions waiting any more word on those fusion experiments. The animals were really interested in cold fusion because they were getting killed. Do you know the word cold fusion actually came up in 1956 on the front page of the New York Times? Because then muon catalyzed fusion, which I won't get into, that is that is the acceptable form of cold fusion, that muons, highly exotic particles, could catalyze fusion reactions. Teller was involved with this, Sakharov, other people. In any event, it was announced that it could be done, and it actually made the headlines in the New York Times. Ironically, the New York Times in 1989 waited a number of days before even reporting anything about cold fusion. Anything. And to this day, they have been terrible in their coverage. They haven't written a story on cold fusion since November of 1992. I have continued to send them the information. I will someday compile a list of all the information that I've sent them over the years, including the free subscription to the magazine, and it will be on record what they had in their hands and did not report. This is the problem. This is what it could be or not be. Could it be nothing? At one time, perhaps it could be nothing. In the first few months, maybe the fraction of a year, could be terrible mistakes, and the term pathological science, the science of things that never were. You know, like these other things that are useless to investigate, like UFOs and crop circles and psychic phenomena, all those things that have a huge database of very interesting data, but which the scientific establishment deems as pathological or sick, mainly because they don't like it. Nonetheless, cold fusion triumphed. The data is now overwhelming, but let's go through what I've had this slide for a long time now. It could be just low-level nuclear products and the heat was wrong, improperly measured. Steve Jones of BYU felt that way. Still does. No, actually, he rejects everything now. Heat only. He rejects everything, yes. Heat only. Heat and nuclear separate, which I think is the ultimate silliness. Both exist, but they somehow have nothing to do with each other. And then there's some reason, I'm not saying that this I believe in. I fully believe this. This is incontrovertible at this point, in my opinion. It is a unified phenomenon. It doesn't mean that the heat is caused by the nuclear reactions. It means that whatever is causing this entire phenomenon or phenomena are part and parcel of the same thing. For example, suppose we're tapping into zero-point energy. If you can tap into zero-point energy and get energy out, you probably can wreck nuclei and create these nuclear products. Let's just give it that way. Or if it is a nuclear reaction, then obviously it's unified. One-to-one correspondence from the mass deficit to the energy coming out. Categories of explanation: that doesn't fly, that doesn't fly. These are totally the wrong magnitude. They're thousands to millions to perhaps infinitely off. If some of these cells can go indefinitely, Craven's had one go for 7 weeks. One of these CT cells for 7 weeks. Just turned it off. He got bored with it. In Italy, Piantelli had a cell running for 3 months, producing 20 watts excess. 20 watts excess for 3 months. Lots of megajoules. From a little rod, by the way, that was only 1 centimeter, I think, in diameter and about 4 inches long. Nuclear reactions with commensurate, possibly, commensurate excess power. Something else even more wonderful: nuclear products are auxiliary to the heat effect. I'm tending in this direction. Nuclear products auxiliary to the heat effect. But I'm fully open. I don't care. I'd love it to be that, because if that is true, then it's starflight time. We can run starships. And in fact, if there are starships visiting us, or if they have visited us, I'm sure in some way this type of energy might be involved. I feel strongly about that. I wrote the Starflight Handbook, by the way, in 1989, and while I was writing it, I knew that cold fusion was real, and I wanted to put that in, but the publisher wasn't too happy about that, so we didn't put it in. But the next edition will have maybe the whole book will be on cold fusion, new energy-powered starships. Well, we all know that they flew in December of 1903, December 17th. They were ignored for 5 years. The same thing is happening with cold fusion, and they even went to France to try to get commercialized because they wouldn't be heard in the U.S. We had another episode with affected the world a little bit. Goddard, the Germans picked up on his patent, made the V2s, then we had the space age. This was totally ignored. The New York Times said, of course, that this man didn't know basic physics. Rockets couldn't work in vacuum, but we all know that the New York Times was wrong. This is what the New York Times said about cold fusion in 1989. They said it was a horror show, the artificial heart, and cold fusion milestones in the history of entertainment, if not science. One wonders whether they will apologize. I hope they do. It's a good newspaper. I read it a lot. But I look in vain for cold fusion stories. This was the last cold fusion story. Actually, they had one recently on cold fusion. They called it cold fusion, but it was hot fusion. It was labeled cold fusion. It was dealing with sonoluminescence and the idea that maybe the temperatures in these little sonoluminescent bubbles, cavitation bubbles, this new phenomenon, that was a phenomenon that could deal to hot fusion, but done in the cold, so to speak. But it was really hot fusion. They mentioned nothing about cold fusion. They didn't even mention the fact that there was a corporation in the United States called Equest Sciences on the West Coast that does cold fusion using ultrasonic activation of palladium. Very strange. This was the last cold fusion story, November 17th, 92, after the third International Conference on Cold Fusion. And we'll have our break shortly. But let me leave you with some, this is just the introductory part, myths against it. No credible evidence. That's gone now. If there is evidence, they don't need to explain where it comes from, even if it's tens to hundreds of megajoules, million joules per mole, which would be a very good hand grenade. It's kind of like having buying a AAA cell, you know, from Kmart and saying I got a 4,000-pound car that, with suitable gearing, with my little electric motor, I can get that car going up to 100 miles an hour from that AAA cell. Stuff like that has come out of cold fusion cells. A megajoule is a lot of energy, and that's what we've been seeing in cold fusion. But I think physicists who thought that they knew about orders of magnitude don't seem to take them very seriously. They said there's no credible evidence for nuclear products of any kind, low or high. If there is evidence, it's not important. Oh yeah, all these arguments have been made. The negative DOE report was not a rush to judgment. It was very carefully considered, even though in all the books, you can read them. Read Taubes's book, Bad Science. Read Huizenga's book, you know, the head of the DOE panel. And all those books document what the people said on that panel that were biased from day one. It would be like having all O.J. Simpson's friends on the panel. Actually, they probably were on. They were on the panel, okay, on record, internally, that this was utter nonsense. They shouldn't even have a panel, Huizenga said, and they claimed that this was not a rush to judgment. While this report, issued in November '89, was being foisted on the American people and the world, okay, to kill hope, literally. Kill hope and kill people. I regret to say it. People have been killed by default. They weren't killers. They didn't want to kill people. But by the delay of years and months that this technology gets implemented, X number of people have died from air pollution and other bad things just because it has not been taken care of. But it was a rush to judgment. All cold fusion experiments are non-reproducible. That is baloney. It was perhaps the case in the beginning, but certainly there were reproducible things that were emerging at that time, and there was a rush to judgment. Japan, they used to say that this doesn't exist. Now they say it exists, but it's stupid. All right. Goalposts move again. But nonetheless, conferences kept going. After I resigned from MIT for reasons we'll go into later, there was the Como conference, which I did not get to go to, in Italy, in Como, Italy. That was the second international conference. The first international one was in Salt Lake City. The third was in Japan, Nagoya. I was there under the auspices of none other than many of the Japanese top physics research societies, including hot fusion people. In Japan, for some reason, much more politeness, cooperation between hot fusion and cold fusion. They don't like each other, really, but now that the hot fusion people in Japan know that they're cooked, they'll probably just switch all over to cold fusion, because that's where the money is anyway. The fourth international conference was in Maui, Hawaii. I went to that. That was lovely. Maui was lovely. Wonderful conference. Electric Power Research Institute produced proceedings with papers this thick. That thick, friends. Papers. Okay? And the fifth international conference occurred in Monte Carlo, Monaco. I went to that. Lovely place, too. We know where to have our conferences. And we have to relax from the cold fusion war, after all. Okay. Popular Science, in August of '93, did a wonderful story, very balanced, as appropriate. They've kind of disappeared. Jerry Bishop of the Wall Street Journal, who normally does these things, he did that. Normally does cold fusion. He's been hiding out on us. He did that. I was quoted in there. Huizenga was quoted in there. It's all on the record. Kind of an interesting story. And that led, by the way, publicity is very important. As the chief science writer at MIT, I can tell you it's important. Many scientists don't realize how important publicity is. Publicity helped kill cold fusion. You'll see that later, how they did it. How the MIT hot fusion people launched a publicity campaign that they'll never owe up to against cold fusion, okay? And then they have the audacity to say that the announcement of cold fusion at a press conference was a bad thing. You should see what they did. Wow. Okay, but the point is, we got people who saw this article who came out of the woodwork. They said, oh my God, the hydrosonic pump. we have something that's over unity. We've never understood why it is. Could you help us out? Maybe it's cold fusion. All right. So a lot of things that people are seeing that are obviously anomalous are now coming out of the woodwork. It's wonderful. So I'm all in favor of publicity. This was a wonderful article by Dr. Storms of Los Alamos. See, cold fusion coming out of the garbage can. Okay? They threw it in the trash can, but it's coming out. And this was in May, June 94. Wonderful article. I actually had an article that was ready to go in 91, and it had been approved. But the physics department got to it. It was approved by the editor, former editor. They got to it, and they, Feshbach, world expert on nuclear energy, nuclear physics, he said to me, when I asked him why he objected to this article and killed it, helped kill it, he said, I've had 50 years of experience in nuclear physics, and I know what's possible and what's impossible. And then I said, well, Dr. Feshbach, would you at least look at the latest evidence as reviewed by Dr. Storms, who then, years later wrote this, or Dr. Srinivasan from India? And he said, no, I will not look at any more evidence. It's all junk. Got very angry, hung up the phone. That was it. And that was Dr. Storm. We started a magazine. Unfortunately, it was with the wrong publisher. It was called Cold Fusion originally. This was our first issue out of Peterborough, New Hampshire. That's the wrong place. It no longer exists. The guy puts out a little newsletter, which isn't worth the paper it's written on. But this is our second issue. There is a third issue. I didn't bring along a slide of it. But it just shows that in the spring of 94, we were rolling. And we'll get on to the evidence real soon. We'll have our break. But let me end this phase of our meeting today here with three more slides, then we'll have our break. Let's summarize all of what we've just now gone through. And again, do diligence, do your own research. I'm telling you what I believe. You look in and find the data yourself. I'm not telling you to believe this. I believe it fully, just like I believe airplanes are flying, okay? I can measure things. I know how to measure. But you do your own diligence. But here it is. Theory cannot be used to reject experimental evidence, no matter how strong the belief in the universal validity of past theory. You would think that every scientist on Earth would believe that, right? They don't. They don't believe it. They pay lip service to it, but they don't really believe it in the practical sense of, if you see something new, by God, take it seriously and see if there's a new theory. I thought science was all about that. New things, new theory, new phenomena. But if you keep with the old theory, how can you go anywhere? It's stupid. The process of science today is incremental change, and occasionally breakthroughs are allowed which are within the framework that they want. They don't want the breakthrough that's out of their framework. A paradigm problem. So we have the paradigm police. Extraordinary claims do not require extraordinary proof, just proof. That's it. Now what they want, the goalpost keeps getting moved. The latest position of the goalpost is, all right, you have a kilowatt reactor with 1 watt going in. Okay, we sort of believe that, but that doesn't rule out the chemical explanation. So therefore, you must provide us with the reaction before we will believe it's anything new. Complete abandonment of logic. This is the mother of all anomalies, in my opinion. What will happen after this great turnaround? Will it be business as usual? Will it be widespread rejection of the scientific establishment? Increased acceptance, a possibility that other anomalies might be real too? I believe so, and that's a very healthy thing. The scientific establishment does not want that to happen. They do not want to be shown as having defects in their methodology so that UFOs and other things become reasonable things to study. I'm not saying UFOs are real. I'm very interested in them myself. Crop circles, psychic phenomena, such as being measured now at laboratories in Princeton and even in the Central Intelligence Agency. Okay? There may be a new metaphor in the language. Oh yeah, it was just like cold fusion. But instead, it won't be a bad thing, it'll be a good thing. It'll be like, yeah, they did a cold fusion on it. In other words, they got rid of it, and they shouldn't do that. Don't do a cold fusion on things. Now it's the other way around. Let me give you, then we'll go to, I'll stop right here after this question. We'll take a break, and then we'll come right back and do the evidence. overwhelming evidence and see some videotapes and slides and things. What would it take to make cold fusion disappear? Simple. The exceedingly improbable determination that systematic errors have been made by researchers in half a dozen or more measurement areas: tritium, heat, neutrons, charged particles, gamma rays, helium-4, transmutations, in each of which diverse experimental techniques have been applied. Now, before we had very powerful cells, that's what would have been required to get rid of cold fusion. And of course, I never thought for a minute that it would go away. Could have gone away. All the experiments could be wrong. Doubted it. Said I doubted it in 91. I was right, I think. Now we have to add another thing. I'll add it for the next lecture. You will have to get rid of all commercial devices that are producing multi-kilowatts of energy with either no input or minimal input. So once these commercial devices start coming out, I hope that the physics establishment is ready to get rid of them all, because that's what they're going to have to do as they come off the assembly line to make this disappear. It will be impossible. And so the energy source has been unleashed to the world. And let's come back after the break. We'll break right now and enjoy some coffee. Let's come back in 10 minutes, okay? Come back at 2:15, okay? Boom, this is part 2, cold fusion part 2. And we're going to see a little videotape in just a few minutes. May see 2, actually. There was a very large meeting in Anaheim, California, December 5th to December 7th. Very historic time, I feel. This was a major industrial trade show in Anaheim at the Anaheim Convention Center. And so we have Texaco and all other, fossil fuel companies, nuclear companies there. But a very unusual exhibit, the most important one in the entire place. This substitutes, by the way, for the video. I don't have videotape of that cell at the conference. Don't worry, this is as good if not better, because you really can't see anything from a videotape. We'll eventually have a videotape. I will show you their commercial videotape, which is very good, of their general process, so that those of you, the cognoscenti here, chemical engineering people and physicists, might get some more insight. Feel the heat. What a wonderful poster. You can feel it. It's not, it's not an experiment where you come up to it, it's hot. It's like a hairdryer. And there was their cell. I wish I could have been there last week. I have teaching responsibilities, so I couldn't be there. But next time. And that was their booth. They have a very nice logo. Okay, Clean Energy Technologies. By the way, this is Dr. Patterson, the inventor, and his grandson, who's the CEO of Clean Energy Technologies. Nice young blood, ready to go to help end the fossil fuel age. One company at least. This is their ad in our magazine, Clean Energy Technologies, the hand with the sun, and showing the essence of their technology, which is beads. Plastic beads with a copper flashing and a nickel layer, palladium. I was asked, here are some of the U.S. patents that cover it. There was one issued in 93 that talks about the process. It doesn't talk about cold fusion, but it's obviously referring to an energy-producing source. We'll do the little videotape now, and then we'll get into, this is the shockaroo, this is the cell. There it is. You'll see later how this works. The heating is done right in there, in a 40 milliliter volume with beads, aquarium pump here, heat exchanger, and a fan blowing the 1,000 watts of heat out. And the calorimetry is very simple. It's just temperature in and temperature out, delta T and flow rate. Power input is measured with standard techniques. We'll get into that. Let's do the videotape first of 2 things. I think let's do their industrial videotape first. The Clean Energy Technology videotape. It will go on both of these monitors. And let's give them this is their point of view. This was before this conference, but it's a wonderful tape. And then I think we'll do Dr. Craven's a bit. I think that would be fair to him. And we'll play it.
In 1989, Drs. Pons and Fleischmann, two scientists in Utah, shocked the world with their announcement that fusion reactions could be achieved at low temperatures. Since then, hundreds of scientific organizations around the globe have quietly continued their quest to harness this potentially unlimited energy source.
The sun's fusion reaction is the ultimate source of all life-sustaining energy on Earth. Even the energy contained in the fossil fuels we use today is the energy of the sun captured by plants and animals millions of years ago and then released when we burn these fuels in our power plants and vehicles. These energy sources are inefficient, expensive, and most important, limited and non-renewable. Science has been looking for a solution to this energy problem for years. Clean Energy Technologies Incorporated has the solution today. Clean Energy Technologies, or SETI, based in Texas, is a private corporation formed to be the exclusive licensing agent for the technology developed by Dr. James Patterson. Dr. Patterson has invented an energy system that will solve the problems of dwindling energy reserves and satisfy the growing energy demands of today's economies without destroying the environment. It will entirely change the current methods of energy production and utilization. A safe, reliable, and efficient way to harness the energy of the sun using the most abundant resource we have on Earth, water. Dr. Patterson has discovered that the excess heat generated by the interaction of water, palladium, and platinum can be efficiently captured and harnessed. This discovery is so profound that conventional science is now trying to understand its theoretical and practical implications. The technology is covered by SETI's 4 patents. These are the first patents of this kind to be issued anywhere in the world. This new hydrogen energy is more commonly known as cold fusion. Clean Energy Technologies is proud and excited to present the fascinating story of the Patterson Power Cell and the reality of a clean, abundant, efficient, economical 21st century power source that is under development today. A source not based upon the burning of fossil fuels nor the splitting of atoms. Hydrogen that is found in every molecule of water is used to stimulate an excess heat reaction that generates a tremendous amount of energy. That heat, then, is transformed directly into other forms of energy. At the same time, hydrogen and oxygen gas is created as a byproduct. SETI was formed with the prime objective of making this exciting new discovery a commercially viable energy alternative. Dr. Patterson originally developed much of this new technology in the early 60s and 70s while working on the amino acid analyzer, which is the foundation of all of today's DNA analysis. He is now SETI's chief scientist. This is a diagram of the system for the electrolysis of water developed by Dr. James Patterson. This system is unique in that it is a closed-loop continuous circulation system that uses either light or heavy water as the flowing electrolyte. The electrolyte flows through the entire system and comes in direct contact with the electrode, allowing high current densities and high energy fluxes within the cell. The design of the system allows inline or online diagnostic testing without removing the cell from a production array. There are obvious cost benefits to this system. It utilizes light or ordinary water as the electrolyte and minute amounts of precious materials in the electrodes. The flow design is superior from an engineering standpoint, signifying a promising scale-up for commercial purposes. The electrolyte is drawn into the circulation system from a cooled feed reservoir by means of a constant volume, stroke rate controlled pump. The medium, or water, is transferred by high-pressure Teflon tubing using stainless steel connectors. The pressure of the system is continuously monitored by a pressure gauge connected in line. The medium then flows through a stainless steel filter containing a cellulose acetate screen. This removes any colloidal materials in the medium and allows the composition of the electrolyte to be monitored at all times. The Patterson power cell shown here has already been scaled up to 4 times its original experimental size. With each scale-up, we have seen significant increases in the relative heat that is being generated, as well as other operating characteristics. The research cell is composed of non-conducting industrial-strength glass that is 1.9 centimeters in diameter and 6 centimeters in total length. The heat-producing reaction takes place inside the microsphere bed, which is less than 2 centimeters in length. This small area produces extremely high energy densities. Notice that the design allows for compression at both ends of the cell. This is done in order to get uniform microsphere bed packing in the cell, which is a vital step in the production of excess heat. O-rings are fitted around these movable non-conductive ends, which are compressed by means of plates and screws on the outside of the cell. Temperatures are measured at both ends of the cell by glass-encased J-type thermocouples that are in direct contact with the flowing medium. Contacts are mounted on platinum screens forming the cathode and the anode. The contacts extend from inside the cell and are connected to a constant current power supply having both positive and negative terminals. Input and output temperature, current, and voltage are carefully measured and recorded on a multi-point strip chart recorder. A backup measurement of current and voltage is also recorded. The electrolyte is composed of light water and 1 to 2 molar lithium sulfate, depending on cell resistivity. The medium enters the cell and then directly contacts the coated microspheres, producing an excess heat reaction. Heated water then exits above the cell. The circulation of the electrolyte through the cell allows for high current densities and energy fluxes within the cell with no complications. The cell design allows for increased conductivity of the electrolyte after hydrogen loading. A significant benefit of the system is that the flowing electrolyte can be used as the heat-to-energy transfer mechanism. The coated microspheres are the highly specialized catalysts for the excess heat-producing reaction. Clean Energy Technologies has focused a large portion of its research on the development of these microspheres and now has 2 patents that specifically cover their use, design, and the substitution of other materials. Using a complex plating process, various metals can be substituted or combined to produce effective results. This diagram illustrates the nickel-palladium-nickel configuration, which is effective in our light water system. This is the microsphere before the plating process begins. The base of the microsphere is composed of cross-linked styrene divinyl benzene, a stable cross-linked copolymer that can withstand extremely high temperatures. In this example, copper chloride is added to form a strong bond with the polystyrene substrate by exchanging hydrogen ions with the copper metal salts. This creates a microsphere with a thin copper flash coating that performs uniform catalytic functions without creating hotspots that would otherwise blow the metal coatings off. Various metal coatings are now applied to the conductive microspheres. A nickel coating of micron size is added by means of an electroplating electrolysis process. Then a micron size layer of palladium is added by either the electroplating or the electrolysis process. Finally, an outer layer of nickel is added by the electrolysis process. This microsphere design allows for extremely short charging times at low current. The normal charging time is approximately 4 hours at 0.05 amps for this microsphere configuration. Because of the geometry and the use of many microspheres in the form of a bed, a large surface area is created upon which the reaction takes place. The microspheres utilize less than 1% of the amount of palladium used in other electrolytic cells of comparable size. Another property of the coated bead is its ability to withstand both compression and expansion forces of over 30,000 atmospheres of pressure during the heat production process, allowing it to maintain its structural integrity. In addition, as pressure is applied to the beads in the system, their sublimation temperature rises significantly higher than 250 degrees Celsius. This is the temperature at which the beads change from a solid to a gas at 14.7 pounds per square inch. This fault-tolerant system allows for several microspheres to fail without significantly affecting the cell's heat production. Also, there is a natural fail-safe characteristic built into the system that will shut it down if temperatures rise above specific levels. After the medium leaves the cell, it passes through a liquid-gas splitter. This device enables the flow of hydrogen and oxygen to be measured independently of the liquid flow. These results are monitored by a gas flow meter. The liquid flow rate is measured in the laboratory by means of a graduated cylinder and a stopwatch. The medium is then returned to the feed reservoir without changes to its composition. At this point, the medium is very hot. Prior to re-entering the system, the temperature of the medium is reduced to its original level by a cooling unit at the feed reservoir. In a practical device, the heat or steam produced would be converted directly into other forms of energy. The engineering benefits of the flow system, the capacity to produce enough excess heat to generate steam, the limited use of raw materials, and the positive environmental impact of creating energy with ordinary water will ultimately dictate that this system, or one very similar to it, will be an economic necessity in the future. The results that SETI has achieved have been very impressive. The Patterson power cell using light water repeatedly produces excess heat yields of over 1,000% at low currents and 250% and above at high currents. That is to say, for every 1 watt that is put into the system, at least 2½ watts are recorded exiting the cell. These results are 100% reproducible. In addition, there have been many individual runs that have significantly exceeded 500% at the higher currents. Here we see the gases and the liquid as they exit the cell. The medium is actually turned into steam due to the high temperatures that are created. Over the past several months, SETI has worked with several individuals and institutions that have independently verified these results. SETI has focused its aggressive research on a system that can be economically scaled up to commercial power levels. SETI is scaling up the size and efficiency of the cell and expects to produce 1 kilowatt of power as part of a larger 250 kilowatt power array. To achieve a more rapid advancement of this technology, SETI is selling research and development licenses for specific applications. Cells and beads will be available to those who have serious interest in purchasing research and development licenses. SETI is also actively seeking strategic partners to join us in the development and commercialization of this exciting new technology. The ramifications of this discovery are profound. It will have a direct impact on every individual, home, industry, and every mode of transportation. SETI invites you to join us in our journey as we move toward the fulfillment of the human quest for a clean, unlimited, economical energy source.
Well, they far outdone themselves. The cell that they said they were going to get a kilowatt, and they got it. Of course, that's a factor not of 10 to 1, as was in the earlier, that industrial film is old. That tape, by the way, was at the Monte Carlo conference in Monaco in April of 95, okay, this year. But now, of course, they have 100,000%. Am I correct on my zeros? These zeros are getting quite impressive. Let's be careful. It's 1,000 to 1, which you multiply by 100, or 100,000 to 1. 100,000%, excuse me, 100,000%. But I will tell you, my good friends, that there is a phenomenon which was documented by Pons and Fleischmann in Physics Letters A in 1993 when they turned their cells off. After the water boiled off, you'll see the boil off on one of the films too close to the sun. They have the so-called heat after death phenomenon. In other words, after turning it off, the reaction persists, and the heat went on for hours. CT does not like to have this talked about too much, but I know for a fact that they can turn their cells off after they're properly triggered and initiated, and there is no input power. The input power on several tests, one test now let's understand what this, we're going to talk now about what happened this week, the Pearl Harbor of the fossil fuel age, December 7th, 1995. Almost a century after the discovery of X-rays in November of 1895, which upset everything a little bit. That was an industrial meeting. They were not there to convince the hot fusion physicists, the people on the email, the forums, or anything. There were some flaws in the general hubbub of things, but overall there's no doubt about what was seen there. Okay? And we'll explain it. We'll go through one by one. But what they did is they had an exhibit, as you saw on the slides. They took it periodically to the hotel room where they could talk to some very large industrial partners that are lining up now to get these research partnerships and licensing fees. They showed them like a 5-hour run here and a 4-hour run there. They didn't have it running continuously, as they did, by the way, at the recent meeting in October, at the hot fusion meeting in Illinois. They had the cell running at 80 to 1, 800%. Where is that? Where is that article? 80 to 1. Yeah, there it is. In this latest issue, Jed Rothwell's description of how they went to a hot fusion meeting, and there were exhibitors of various kinds, and they demonstrated a cell putting 5 watts out with 0.06 watts going in. With full flow meters, thermocouples, it ran for 4 days at 80 to 1. That's the end of the hot fusion process, as far as I'm concerned. Not that that's an irrelevant question of hot fusion. It's a silly thing to even talk about, but they have been bad people in this field. Let's go back to let's talk about what was exhibited. Let's go right through the various equipment. Very interesting. Now, I wasn't there, so I'm relying on my excellent colleague, Jed Rothwell, who saw this and told me secondhand exactly what's going on. I'm missing my pointer. If someone sees the pointer lying around, you got it? Good, I like it. I like to use a pointer. Okay, this is just a tabletop. It almost looks like a science fair experiment, and in effect it is. But isn't that something, if you look back in history, Michael Faraday's equipment didn't look half as good as this. And what did it do? It turned, it's like electricity. It turned the whole age around. This will do the same thing. I'm sure we'll put this in the Smithsonian at some point. By the way, is it possible to turn those, well, okay, leave those lights on. Might make the contrast a little better. Let's focus in on particulars here. I have a little closer upper here. Yeah, let's describe what's going on here. Now, this is a real cell. The cell actually is inside. You can't really, there is tubing, large gauge plastic tubing as a protector, because the rules of the conference were, if you have something that's very hot, you don't want people grabbing it and getting burned. So you have to have this tube. This external tube is irrelevant. It's just a protector. Inside this foam padding insulation is the cell, just like you saw in the film, a little bigger, 1 inch in diameter, about 4 inches long, with 40 cubic centimeters of beads, new design beads, which they are being tight-lipped about for now. I suspect that they are ceramic, designed to go to very high temperatures. I suspect they are, but I'm not sure. I don't know what they are. All I know is that it's still light water and lithium sulfate electrolyte. No heavy water particularly. Okay, the water is pumped through. Here's an aquarium pump. Just an aquarium pump. By the way, with one of those magnetic operations, so that the impeller part of the pump, is not connected to the electric part. It's perfectly clean. It doesn't go through, no danger of hurting the motor. So you just pump the water through. It's just a flow system. Now, by the way, in case anyone is super skeptical, could this pump create 1,000 watts of power? No way. They wanted to close that little loophole off. They had simple power meters hooked right into the AC line. The entire AC power of the pump, the electronic instrumentation, all these things, everything else, the cell itself with its puny little microscopic amount of power consumption, was all monitored at a central location, and the total wattage going in was something like 70 or 80 watts total. But don't be fooled. That has nothing to do, of course, with the real input power, of course, to the fundamental process. Yeah, you could do this by convection or by many other means. The pump power is not part of the process. The process is the delta T across the flow volume times the flow rate times the specific heat of water, and that's the 1,000 to 1. The fundamental process is 1,000 to 1. Yes, the auxiliary pumps may be more. Who cares? It's still 16 to 1. Okay? So, you know, this is hot. This is a, you know, if anyone had heard, oh yeah, they did 16 to 1, they would have been happy, right? But they really did 1,000 to 1 or more. There's James Patterson that you've seen. He lives in Sarasota, Florida, by the way. He doesn't want to get involved in all this business stuff. He's turned it over to his grandson. He just wants to fish. Got plenty of money. Had dinner with him out in Monte Carlo. This is Jed Rothwell, my colleague, contributing editor to the magazine. Patterson, his grandson, and that's Dr. Tom Passel of the Electric Power Research Institute, one of the good guys in cold fusion. There are bad guys against cold fusion at EPRI. The EPRI program, all the EPRI programs have been cut back in all areas. So cold fusion has been cut back. But Tom still gets a nice salary for working on cold fusion. Most of the work that he used to support from EPRI, millions of dollars a year, is now being funded by Japan. SRI International is now being funded by the Japanese New Hydrogen Energy or Cold Fusion Organization. But he was there at the conference. There were many other cold fusion people too, and there were some good hot fusion people too from General Atomics who are very interested in this. General Atomics of San Diego is very interested in cold fusion. They know the writing's on the wall. No one's going to build tokamaks, therefore they better get into something new because they, you know, there's some sharp people there who know what's going on. There's an instrumentation again. Here's the close-up of the cells, and you have the, I think the cathode is at the bottom, the anode is at the top. You know, the current conductivity goes through the water, through the layers, you know, circuitously, through the layers of material on the cells. You know, the beads. The beads touch each other. It must be a very complicated process. I'm not presuming to give the exact dynamics of it, but obviously there are some very interesting things going on in such a fluidized type bed. Not literally fluidized, but sort of looking like a fluidized bed. Yes, it's contact on the bottom, like a screen at the bottom and a screen at the top. So you have a platinum, you have a screen at the bottom and a screen at the top. Yeah, yeah. For total conductivity, whether the new cell design has it going across or vertical, I don't know. You can well imagine, use your imagination. They can use all kinds of geometries, and they probably will, and this will become sort of a universal process. This is the business end, so to speak, where the heat comes out. It's kind of funny in a way. A little muffin fan, you know, the kind that you have here in the TV to blow hot air out of your TV. When it pulls the air out. Put your hand over there, and there's a blast of hot air. Blast of hot air does not equal 8 volts in to the cell and 0.1 in one test, where it was going at a 1.344 kilowatts, does not equal 0.18 amps, which was on the meter, and 8 volts. That's 1.44 watts. You don't get a Christmas light creating a hairdryer. Simple as that. And that's the fundamental fact of this whole experiment. And if it goes long enough, it's megajoules per, you know, whatever, okay? It's a kilowatt per hour. 1,000 watts times 3,600 seconds in an hour is what? 3.6 megajoules, right? And you go 5 hours, and then you're up to, you know, several tens of megajoules. So the whole thing is obviously a profound reaction. Much as we don't want to believe it, or some people don't want to believe it, it's there. It's just a simple high school calorimetry. These are the holes where the air comes in, goes through this tubing. I wish they had made it a little prettier, but it's kind of nice that it's crude, just like Michael Faraday's experiment, Galileo's experiment. All these things that started off very simple that changed the world. Goddard's rocket, the Wright brothers Flappy thing, and Kitty Hawk. There's the whole setup. They ran out and they bought a bottle, I don't even know what this is, Aquafine it's called, water. What's it used for? In film, what? Aquafine it was called. They needed some, they didn't bring along, this was all very rushed, and they brought it all along and just, oh, get some distilled water. Oh, here's some Aquafine, throw it in. I love it. The in fact, the cruder it is, the better it is. And it's in a way good that there were a few glitches. One glitch was that the control cell, which you saw, seemed to be producing at one point a delta T across the beads, all right? In other words, they suddenly saw 2.6 degrees across the beads, which would be a high power, you know, 100 watts or 200 watts. And so that gives the skeptic something to yell about. It turns out that there's some unknown glitch so far in that. Believe me, Dr. Cravens, who knows what he's doing, saw a delta T of 0 at some time before this whole thing came here or while it was there, you know, 0 delta T across the control cell of ordinary shot, you know, lead shot coated with tin or something. It was thrown in there. They probably should never have brought a control cell, because if you fail the control cell, as they did apparently, and get an apparent excess, then the skeptics say, oh, you know, you're getting energy out of shotgun shells now. This is impossible. You're fools. Goodbye. And so it's a nice trap to let them go yelling and screaming for another few more weeks or months. You know, they'll have fun with that. They're funny people. That's it. And there's the fan. I guess more and more of the same thing. Oh, here's when it was reading 8.5 volts across. No, that was delta T. I'm sorry. That was one time when it was a delta T. Oh yeah, write this down. 8.5 delta T, C, across the bed, and 0.023 amps going in. And my colleague told me, I can't confirm this, but this was the one where the power at that time, the voltage at that time was 9 volts, I think. So it's 9 times the 0.023, or something like 0.1, wait a minute, 9 times that would be a very low power, indeed, like about 0.18 watts going in, 0.2 of a watt going in. The 8.5 delta T was, the flow rate at that time was about a liter per minute. The whole thing is, it's about a liter per minute type system. More details. Here's, what was this? This was, wait a minute. Oh, this was 0.66 amps, just showing, yeah, there's 120 volts going into the whole system, you know, wall current, wall power, and, you know, the motor, everything is 0.66 amps. So a fraction of a 100-watt light bulb to operate the entire system and get this miraculous effect. Just to be sure that everyone knew the wall was being measured, they stuck a, what is it? There's the Radio Shack meter showing, you know, 120 volts. But before this is the culminating cold fusion experiment that ends everything, as far as I'm concerned. Because right after this, I think what you're going to see real soon are public announcements. I don't know exactly what the time scale is, but certain major corporations are getting involved now. Whether they fully sign aboard remains to be seen, so I don't want to have to eat my words. I would just predict that within the next 6 weeks, maybe a lot sooner, you will see major U.S. corporations, I'm talking Fortune 500 level. I happen to know the name of one such corporation, who's likely to sign on or have already signed on. And when that corporation is announced, that's it, right? You know, they know what they're going to do. But yes.
Do those beads have to be removed periodically?
They get better and better with time, I understand. But that remains to be seen. Remember, this is demonstration level, but it is not yet, of course, you know, here's a product that we can put into anyone's house and guarantee that the beads will last, you know, umpteen months or years. My feeling, the likelihood is, in my opinion, is that you will see these beads not degrading. My intuition tells me that, but I know from nothing. Maybe they have to be replaced. But it's a very small amount of material. And by the way, the power level coming out is such that the power density in the metal layer is on the order of kilowatts per cubic centimeter. Many kilowatts per cubic centimeter in a flow stream, okay? It is a highly intense reaction in the metal regime, in the metal layer. The total power density is like tens of tens of watts, 30, 40 watts per cubic centimeter, that's big news. Very powerful. Yeah.
What was it that you left implied when you said you know what would happen in a large corporation?
Oh, when a large corporation is involved, since the goalpost kept getting moved, the thing that will allow for the first time what we have not had enough credibility with the media, okay, let's say, so that the media feel comfortable writing about this. However, when a large corporation must tell its its stockholders what it's just done, it has now invested its money into a company in Texas called Clean Energy Technologies that's involved with coal fusion. It must tell its stockholders that. The business writers must write about that. Must. Okay, the very first thing, if anyone should criticize them, will be this company will be called foolish and stupid, and by some, uninformed sources, and the whole thing will come out publicly. Everyone will focus in on it. Business Week will write about it. So, it's going to really change things, I think. Won't end the fossil fuel age overnight, but it will create a big splash.
No, but will the lawyers of the large corporation then go around and stop all small corporations to try to sell products?
Small corporations? What do you mean?
The small businesses who try to get products to the market because the large corporations, while they're only interested in selling to large clients.
Oh, no. Oh, by the way, I'll tell you one thing that will make you happy. This corporation that I know of that is the most likely to be the first on board and publicized is not an energy company. It is not an energy company. So it is not like Texaco buying in and trying to squash it. Yeah.
In the movie Too Close to the Sun,
Yeah.
there's something about an agent of the power company buying up all patents around the world.
No. Eneco is buying up all the patents. They are a coal fusion company in Utah. Their idea for a company, Eneco, is buying all the patents as much as they can to get an umbrella coverage. They have the Pons-Fleischmann patent under their umbrella. Okay, by the way, the SETI business plan, this is very important for any of those who have connections, who might want to get into business. I certainly am tempted with colleagues. All you need is SETI is a young company now, right? $1 million will buy you a license, a non-exclusive license to develop any technology you want that will use their beads, renewable every year for $500,000 per year, which would be enormous if you can't make sales, okay? But if you were to, my thought is, immediately go out and make a 2 kilowatt room heater, right? Make a 2 or 3 kilowatt room heater, package it up industrially, get a license from SETI, and run with it. That's a business. Make a furnace for a house to replace, some few tens of kilowatts, and throw it in the basement, sell it for, who knows, $10,000. People would gladly pay that to eliminate their oil delivery, even if they had to borrow the money. At $5,000, you couldn't make them fast enough. Okay? So there are many, many business opportunities. I'm sure they will be tried. Let's go back and revisit the older days, though, of the evidence. Sorry to do this, but this was there on the table before SETI. This was there, that a certain current density in these, this is Storms provided me with this, at a certain critical amps per centimeter square on the palladium system, we give these various watts per cubic centimeter energy density, watts per centimeter square, off the cathode. It was clear that there was a phenomenon here, and it was following certain rules. You couldn't do it below here, and you did it over here, and there were certain things that were going on. And look at this. This was a summary of all the production of energy as a function of excess power in watts in all these experiments that SRI did at different loading ratios of deuterium to palladium. Look at it. It's going up in a prescribed way. There's a phenomenon there. There's a phenomenon. Okay, this is why the whole business of coal fusion is nonsense, makes no sense. Because good scientists like Mike McCubry, very conservative man, okay, and great that we had him, found these things that were happening. This was very systematic. Here's from Kunimatsu in, Hosogawa et al. At Imra. Right, Kunimatsu's there. 2 different types of systems, different power ratios. Let's see, D to PD ratio. They found this 2 on the composition. They found a a similar effect. This was found very early on. This was SRI. You'll see this in too close to the sun. They found at SRI that they got an autoradiograph through two thick layers of film, and there was some fogging. By the way, in one of the issues, the third issue of our magazine, Dr. Srinivasan of Bob Atomic Research Center shows how you too can do this with loading. You load a palladium wire, and you will absolutely reproducibly get film fogging of unknown ionizing radiation origin, he believes. There was that, and Bob Atomic Research Center had done, they had done some other types of cold fusion experiments. There was another example of an autoradiograph from a gas discharge experiment. They had that early on. This has been around for a long time now. I mean, this is a 7-year war we've had, now ending. Tritium activity, Bacchus et al. At Texas A&M. Remember, Bacchus was crucified by Taubes as having done fraud. It was all circumstantial evidence. There was no evidence of fraud. It has been now clearly stated, clearly concluded that there could not have been any fraud, but the perception of fraud still continues. John Huizenga of the DOE panel repeated Taubes' accusation. It is a disgrace. It is outrageous, and we will take care of Mr. Taubes eventually. He'll be one of those who will be very sorry when this cold fusion war comes to its conclusion. He is unrepentant, they all are, and those who are unrepentant will be dealt with. They should be, because this should not ever happen again. What if it happened in a medical? It probably is happening. It is, well, what if? It is happening in medical discoveries whereby critical medical life-saving therapies are ridiculed and railroaded out of town just because a certain establishment doesn't like it and calls it quackery or fraud. Hopefully that will change as a result of cold fusion. So cold fusion is much more important than just the energy source, which would be enough. But to get rid of and to smash the scientific establishment, it deserves to be smashed. A lot of the stuff that it does is very good, don't get me wrong. I'm a man of the establishment in some sense, but I don't agree with what its behavior has been. I just think that this is going to be a salutary lesson in the history of science. More tritium. This is at Los Alamos National Laboratory. This is tritium production, reproducible in various experiments, way above background, okay, changing with the various currents and so forth. And it's in a Los Alamos National Laboratory report. Isn't this interesting? One of our laboratories is producing tritium, which is an ingredient to hydrogen bombs. The director of the laboratory is doing absolutely nothing about this. We are still talking with the Department of Energy. They're talking about reactivating nuclear reactors and other methods of producing tritium. Meanwhile, right there, it's being done, and no one is acknowledging it, and that is criminal. If that happened during wartime operations, during, let's say we're at war with a country, we needed hydrogen bombs, silly kind of a statement, but anyone who would get in the way of the understanding and the dissemination of that knowledge within the military forces would be convicted as a traitor to the United States. Okay? But it's not a war, so therefore it's par for the course and doable. Reduced radioactivity of tritium in small titanium particles. Isn't that amazing? That work done 30 years ago by Reifenschweiler at the Phillips Laboratory showing the decrease of tritium counts with temperature. Radioactivity is not supposed to change with temperature. They went back to look at their old data. They knew that it was strange back then. Now, with Pons and Fleischmann, all this old stuff is coming out. And look at this, my friends. Tritium counts going along. Here's temperature degree C. And then suddenly, at a mid-range between 100 and 200 degrees C, the counts start going down. Not supposed to happen. One would think initially, oh, the tritium is leaving. You know, the tritium is being discharged. Well, he kept a pressure probe on for the tritium pressure, and the tritium pressure did not start going up and thus being removed from the system until much later. It came down, and then the counts went up again. Incredible. Astonishing. It's now all but certain that radioactivity is influenced by temperature, a to say this. It is influenced and destroyed, perhaps, in certain processes. This is a very heretical thing. This is pure alchemy. It is not supposed to happen. Quantum mechanics and other things say radioactivity is a stable clock. We are in danger of losing some of our clocks now. I do not trust all. I mean, I pretty much trust carbon-14 dating and other dating, but now things are going to have to be considered again. You know, this is very, very scary business. That something that is so rigid as, dating by radioactivity can now be called into question legitimately. Because if one single experiment on Earth shows that radioactivity can be changed by temperature, as that one does, are you going to believe other experiments for sure? Aren't you going to feel a little scared about whether it might be off? It might be. This one will, the head of the National Cold Fusion Institute, deceased institute, okay, because of the politics in Utah, they had fully reproducible tritium. This was in 1993, but of course they got the results in 1991, 2, and so forth. 91. They closed down in 91. They had this reproducible tritium. This was by a guy formerly from the GE Research Laboratories, an impeccable electrochemist, very precise Austrian chap, very ambiguous about excess heat, but totally willing to say, we created tritium, in a paper in the Journal of Electroanalytical Chemistry. And here's Mike McCool. Let's see, what's this? Oh, there's helium results. Helium reports keep coming up. Miles at the Naval Air Surface Weapons Center in the Journal of, where is this? Oh, Fusion Technology, probably. The probability of all his data being due to random errors, that is, the helium coordination level with the excess heat or lack of excess heat, the probability Dr. Miles assigned to that was 1 out of 134 million, 217,730. Almost a vanishingly small probability that his results of helium appearing or not appearing came out. An excellent man, very careful. Low power levels, small helium ratios. Equus Sciences has much more. Here's a heat burst in temperature that was obtained at SRI. This exists. I mean, this is really a temperature excursion that suddenly occurred. You know, these thermometers didn't malfunction. Okay, I mean, this is real stuff. This is on the record. This has been going on. Here's the patent of Piantelli with just a nickel rod and ordinary hydrogen, not even heavy hydrogen. No products found. He has gotten gamma rays off, though. He has gotten gamma rays. The experiment is simply an evacuated chamber with pumps and monitors, and they tried hydrogen and heavy hydrogen. It's very strange, very strange. By the way, they got into it by the back door. They saw some unusual things occurring in medical experiments involving, I've forgotten now actually what it was. Some interesting effects whereby heat on a biological sample on nickel was not going away. And they were in cryogenic temperatures and they couldn't cool it. They couldn't keep it cool. And they thought, oh my God, maybe there's something unusual here. Oh, maybe Pons-Fleischmann effect. They trigger it, they go up a temperature profile, input power, then they do something, magnetic fields or whatever, and they get the same power nickel temperature. They're able to sustain it at a lower heater input power. When they start getting excess, they get watts of excess power. If you believe calorimetry, see this line across here? Here's the same temperature, or that is power level, created by a different input power, a lower input power, after they trigger the reaction. It's very strange. You'll have to read the paper they published in Il Nuovo Cemento. Oh, Dr. Miley, who's in hot fusion, and he's the editor of this magazine, they tried layers of various kinds in little cells, and they got pretty much what a lot of other people are getting, kilowatts per cubic centimeter in the layers, 10 kilowatts per cubic centimeter. This is the man, I didn't bring his results. This is Kevin Wolf, one of the terrible skeptics of cold fusion, actually one of the original finders of cold fusion effects. Then he got terrorized by the whole thing, and so he retracted his tritium results. He shouldn't have. He got these anomalous gamma ray spectra which are shown in, which one did we show it in? Oh yeah, here it is. We published it for him. He was unwilling to publish it, so we just did him a favor. We didn't get sued yet. I'm sure he'll just keep his mouth shut. These were EPRI curves in any event. They were shown publicly at ICCF 5. Where are they? Oh, here. Okay? These are Dr. Wolf's gamma spectra. Many very sharp gamma lines indicating radioactive isotopes that were created in a Pons-Fleischmann cell. He hasn't been able to reproduce it, by the way. He thinks they're due to weakly interacting cosmic particles. He can't, massive particles. He can't bring himself to think that this was a cold fusion effect. He can only get out of it by privately saying that he believes it's some sort of a weird particle. This is nonsense. This is from a cold fusion experiment, simple as that. Nothing from space, just from cold fusion. And that's the Griggs cell, which is of Hydrodynamics Incorporated. A motor. This is their sales literature. It's a heat company. They sell these things. You can buy one for $10,000. They put these in buildings, and buildings have reported saving energy. I mean, 10, 20% on the electric bill. Okay, electricity goes in. It's a way of having no fossil fuel in your building, which could save you insurance rates because, if you don't have fossil fuel, you don't have the danger. So therefore, it's a neat device even if it weren't over Unity, but it is over Unity. A very high horsepower motor, 30, 40, 50 horsepower, rotates something inside there. It's a cylinder with holes in it that creates ultrasonic sound, bubbles, God knows what else. I'm not saying I know what's in there. I'll describe the experiment we did. It just circulates the water. This just turns the rotor, and an auxiliary pump. Where is the pump? There is an auxiliary pump that pumps it around, circulates it, okay, into heating coils with blowers and so forth. But the essence is there the delta T going in here and out here, producing the hot water, is that producing more energy than is going in mechanically? It's a simple question. You can ask that question. And the answer that we found when we went down to visit him, we're not the only ones that found this. It keeps on being found over and over again by other people too. Let me put that back up. We found when this is in the steam mode, this can create steam also. It's obviously steam because you see this big blast of steam coming out if you open the valve. We heated it up, we got it working in what James Griggs, the inventor, said was a proper mode. We had very good meters, most sophisticated meters that they sell for measuring three-phase motor power. The input electric power was recorded and added up electronically to get kilowatt hours, okay, during a 20-minute test, let's say. We just had a barrel sitting on a scale, well calibrated. We calibrated it also. They calibrated it. It was 350 pounds of water, and you dump the steam line in at T0. Stick the steam line in, condense all the steam, watch the temperature rise in the barrel, 50 to 70 degrees Fahrenheit rise. You could immediately determine how many BTUs went in the barrel. And of course, we weren't being careful in terms of insulating the barrel and insulating the pipes. We just wanted to see roughly, is the heat in the barrel from the steam more than the electric power going in? And it was. So it must be about, say, 20, 30%, 40, whatever. These are big numbers. Not like 1%, 2%, tens of percent already over the input power. Now, given that the electric motor is about 15% inefficient, it's even better than you think. This was not the only such device. This device comes out of another device, which we talk about in our magazine, called the Schaefer device, which had a U.S. patent, that itself was reported on many occasions to produce excess energy. And you ask, why should simple plumbing like this do it, and why didn't we hear about this before? Very simple answer. No one was looking, or a few people were looking, and even if you showed it to somebody, they wouldn't believe it. Battelle was shown this. They saw it. They deep-sixed it. This was 20-some years ago. This has been around for a long time, people. It's only now coming to fruition only because of the cold fusion controversy. Here's something else to put on the table. I don't normally talk about this, but there it was in Business Week, May 8th, August 8th, 94. The Gunnerman process. Caterpillar Corporation is on public record as supporting this. It is a fuel called A55. It has now been approved, by the way, by the state of Nevada. It is a mixture of 55% gasoline, 55% water with gasoline or fossil fuel, any other fossil fuel. They use naphtha now, which is, I think, lower, for you chemical engineers, lower on the chain of production, so it's cheaper to make naphtha. It's 55% water. They put it in car engines. It's been tested in fleets, and it gives 30, 40, 50% more miles per gallon at a cleaner exhaust. So you cut down dramatically per gallon of fossil fuel component. All right? So it's a water fuel. They find they need nickel in the combustion chamber. Isn't that neat? Nickel needs to be in the combustion chamber to make it work. Is this cold fusion? Who knows? But it's mighty interesting when a company starts selling a fuel in the United States, it's 55% water. So we have the preeminent examples popping up all over now of excess energy and spectacularly increased energy. It is case closed that the oil age is going to end. It was my little contribution, proud of that. For a time we had a little money, very little always, it seems. I did some experiments on the Takahashi, Akihito Takahashi's cold fusion process. This was very fast. We did it. We thought we had excess heat. We're not sure we ever saw the excess heat. But what we did was we verified the calorimetry. We turned over some of these, these materials that we got from Japan to people who had more money, more time, more resources. Dr. Storms at Los Alamos National Laboratory, he verified the heat, duplicated it, peer-reviewed internal to Los Alamos National Laboratory, guaranteed excess heat out of this process which cycled the power. It was a pulsed input power situation. But we did a nice little effort in the basement in Bow, New Hampshire, where I live, near Concord, and it was fun. And the calorimetry holds up. It was clear that Takahashi in Japan knew what he was doing. It's clear that Storms knew what he was doing, and it's pretty much case closed that it is real. Let us take a break right now. We'll come back, we'll finish off, we'll do heavy Watergate quickly, we'll do some electric motor over Unity. I've already talked about the Griggs stuff. And then we'll have dessert. We'll see Too Close to the Sun. Let's do heavy Watergate really quickly. We've done a lot of the evidence. I think you're beginning to get the picture. But there was an incredible attack against cold fusion. I was the chief science writer at my alma mater, wayward alma mater, MIT. At the time, it provided a unique perspective. I had been there since September of '87, so I was a good man. I was known as a nice fellow, a person who was happy with hot fusion. I mean, I was the one who introduced Ron Parker, the head of the $200,000 a year man, head of the Plasma Fusion Center. I introduced him to the Wall Street Journal 3 weeks before cold fusion broke. And I was proud of that because, you know, I was exposing hot fusion and how good hot fusion was going to be for the world. It was. I was always interested in hot fusion, but I didn't get much back from them later on. They turned against me, it turned out, behind my back in many cases. It all began on the night of April 30th, 1989. Remember, the announcement occurred, there was great disbelief, but polite discussions. Everything in the news media up to that point, up to May 1st, May Day of 1989, was politeness and sweetness. We will check it out, we will find, but behind the closed doors was a deliberate campaign to discredit the whole business because they didn't believe it from day one, and they knew their program was threatened desperately if this was right. Okay, on the night of April 30th, 1989, I got a late night call from the head of the Plasma Fusion Center, a desperate call from Ronald Parker. He said to me, Gene, CBS News called me, and they said that the Boston Herald is going to write a report saying that I said that leading scientists at MIT derided breakthrough cold fusion experiment as scientific schlock, will release a report today charging 2 University of Utah chemists with misrepresentation and maybe fraud. Okay, Parker said to me, I did not say any of that. Of course, I certainly believed him. Well, The Herald is a tabloid, and I did not know Nick Tate at all. I later came to know him. Turns out that he had Parker, he should have told me, I'm a representative at MIT in the news office, if he's going to design or engineer a big publicity thing, many professors do that, they design publicity campaigns for their own projects, he should have told me. It's not my job to stop him from talking to a reporter secretly. The Boston Globe, by the way, at the time, the competing newspaper, was being very positive about cold fusion, that it might well exist. It was still in a neverland of is it right or is it wrong? But Parker and his colleagues wanted to axe it. They had already done some experiments that convinced themselves that Pons and Fleischmann had completely screwed up, as they had, on their neutron measurements. And they even began to suspect that Pons and Fleischmann had shifted their curves, showing gamma curves, showing that there were 2.5 MeV or 2.45 MeV neutrons coming out. Okay? Whatever. They thought Pons and Fleischmann were sick and silly, and they had to get rid of this because it was detracting from their program, so they called in Tate. They asked Gene to write a news release at midnight, which I did, gladly, to the UPI, AP, and so forth, denying this report, saying he did not say fraud, he did not say schlock science. So I was used. And it was a complete fabrication. Parker had said all those things, and worse. Tate was actually pretty kind to Parker. Parker used the word fraud 5 times on the tape. I have the tape, by the way. He said, so what, and his sort of ending line with Tate was, you know, what are you going to do with this? So what you're hearing from us, Nick, is that we think this is a scam. That's what he said. So Tate reported it right on the nose. He was almost fired immediately. Fortunately, the tape was home by the editor of the mag, because the newspaper would presume that the professor at MIT was not lying and his reporter was an incompetent boob. But it turned out that Tate was absolutely correct. To this day, Parker does not admit to what he said. There were subsequent radio broadcasts after I resigned from MIT in which he continues to deny. Now, you think that's just a little personal peek? No. That was the opening shot of the cold fusion war, where it became permissible in polite company to call Pons and Fleischmann frauds and schlock scientists and so forth. The next day at Baltimore, at the American Physical Society meeting, they were hung, Pons and Fleischmann, in absentia. Ridiculed. Numerous reports came out. Nate Lewis of Caltech gave them full blast, you know, on and on and on. This was Parker at the news conference, emergency news conference we had the next day to clarify things. The Herald the next day published the transcript. At the time, I didn't know. Parker told me, hey, this Tate is a viper. He said Tate is, you know, this is out of context, and I believed him. About a year later, I listened to the tape. Tate was right on the money. And the next book that I write will not be so kind to Parker and company, will be very, very harsh on that particular entity at MIT. They held a party for cold fusion, against cold fusion, on June 26, 1989, black armbands optional, sponsored by the Center for Contrived Fantasies. I declined to go to this. This was from the New Yorker. Don't you remember we were at Herb and Sally's, and Herb said he knew how to achieve fusion at room temperature only using gin and vermouth. This was before their data had been analyzed in the calorimetry experiment. So they didn't even have a conclusion on calorimetry yet, but they had a party against cold fusion. Okay? I found this later, much later, as my book was being finished. I was shuffling through papers, and I'm overwhelmed with information on cold fusion, and I come across these 2 curves, which was one of their July 10th. Remember, this is after the wake party. After the wake, in July. Okay? Weeks after June 26th. And there's the light water cell, and here's the heavy water cell. Okay? Parallel runs. They were run simultaneously. And clearly this cell appears to have, at least in this presentation of the data, excess heat. Doesn't prove cold fusion, but it says, hey, there's something interesting here, not interesting there. This is pretty much of a wash. So if you got data like that, you would say, let's go, boys, let's do it again, right? Minimum, if you're a scientist. If you're a politician, what you do is you shift your data and you publish it. This is what they did. They published this data. shifted, this is the light water averaged according to samples, that's okay, but then they shifted down the heavy water data so that this would look okay. And this was published in the Journal of Fusion Energy, which is edited at the MIT Plasma Fusion Center. The editor, talk about peer review, the editor at the don't confuse it with fusion technology. Journal of Fusion Energy is at this place working for Ronald Parker. Mr. Kahn was his name, or Dr. Kahn, nice name. Okay? So 3 days later, the data was shifted. It's much worse. A colleague of mine, Dr. Mitchell Swartz, found all the data shifted points. It was distorted. He found out you could not possibly get a linear transformation for what you know linear transformations. You could not go linearly from the raw data on the heavy water case to this. It doesn't work. So it was highly massaged. In my view, one of the worst cases of scientific misconduct in history, because it led to the suppression of a technology that for years, the deaths of many people needlessly due to air pollution, due to the delta T of this technology not being adopted soon enough. This was the press release denying it, which I signed on, and on the day I resigned, on June 7th, 1991, I publicly disavowed this release as a lie, which it is. It's a complete lie. Professor Ballinger in nuclear engineering at MIT, he made some very choice. At the day we started bombing Iraq, which was fine, I was all in favor of that, Baghdad, that is, he was giving a lecture. He's an ignorant man. I have to say this. He's so ignorant, it's beyond belief. But he came out with one of the best anti-cold fusion statements. It would not matter to me if 1,000 other investigations were subsequently to perform experiments seeing excess heat. These results may be all correct, but it would be an insult to these investigators to connect them with Pons and Fleischmann. In other words, it could be real, but they're so bad and terrible, it's impossible to give them any credit at all. As though MIT, the great MIT, I wear the ring proudly still, somewhat less proudly at this point, because this is what the head of the physics department said when he called up in the spring of 89, and not 89, 91, two physicists, hot fusion people, one of them, had a new theory of cold fusion. They had been invited by Professor Hagelstein in electrical engineering to talk at MIT. He called the news office and said, how did these flakes get on campus? This man is now the Dean of Science at MIT. Parker, on the day I resigned, I showed these curves in public. The way it happened was, I knew that everything was doomed at MIT. They'd shifted the data. My book was coming out. The article for Technology Review had been canceled. It was a terrible place to be. I didn't want to represent this place anymore. I wanted to be free to speak out, and I'm glad I quit. They called in Dr. Frank Close, who wrote the book Too Hot to Handle, okay, from England. They didn't even tell me that this speaker was coming. They knew I was writing a book and had written it and it was ready to come out, but they secretly called another speaker in. They didn't even give me equal time or even a fraction of the time. Not that I really cared all that much, but I went to the lecture. And at that lecture, listening to 45 minutes of Frank Close talking about the fraud, that's the whole point of his book, Too Hot to Handle, that Pons and Fleischmann shifted their gamma curves. So they're fraudulent and everyone else is good. After listening to 45 minutes of that, I said, look, here are the curves. I put them on the wall. I said, Frank, why don't you write this up in your book on the next time? It was as though I wasn't there. Parker, who claims he never saw those raw curves, and probably he didn't. A lower echelon guy shifted the data. This is what he said in public, and I have it on tape too. I'll tell you what my opinion is of that work because I was part of it, and I don't think it's worth very much. That's why it's just published in a tech report. I don't think it's worth very much. And that's why I don't put any stock at all. You can redraw those curves any way you want. I don't think the data is worth anything. The data was not worth anything, according to him, on that day, but it has been used explicitly by the United States Patent Office to say that the effect doesn't exist. And if you want to talk about the most genuine form of fraud, let's forget for a minute that the curves were actually shifted. Talk about the level of scientific integrity involved in allowing one's data to claim something as negative when you publicly state on the record that it was lousy data. That is highly unethical. But of course, when I asked MIT and President Vest to investigate, they went to a pro forma thing, hardly worth talking about, and they swept it under the table. When I left, I warned them. I said, this will not stand. Eventually, this will come out, and it will come out, and it will be highly damaging to your reputations and to the reputation of MIT, and that is going to happen. Professor Hagelstein, brilliant man, formerly of Lawrence Livermore National Lab, working on nuclear weapons. He left because he didn't like nuclear weapons and other matters back in '86. Came back to MIT, a brilliant teacher. He could get tenure anywhere in the country if he wanted to. He had such a high reputation. Very good friend of mine now, by the way. I'm in awe of the man. He may be right or wrong about his theory of neutron transfer reactions. This was his closed-door meeting at MIT, April 14th, 1989. He was almost denied tenure because people objected to him working on cold fusion theories. Fortunately, he persevered, and he did get tenure. Pre-fusion age science research attempted to recreate the claims of Kitty Hawk and concluded man was not meant to fly. He would have been born with wings. Well, that's about it. Close came in, and he gave his expose. That was the announcement, June 7th. Fateful day, turning point for me in my life anyway. I like to say about Frank, find Frank, he wasn't frank, and he wasn't even close. His book is a travesty. Fortunately, it's not even well written, so no one will care about it. It goes into the trash bin of history. Taubes is very well written, I'll grant you that. Taubes is a hatchet man. He's already done hatchet jobs on other people. He thought he would do a little frisky hatchet job on cold fusion. That's his stock and trade, hatchet jobs. He's not a scientist. By the way, he, at the first cold fusion conference with 500 scientists gathered in Santa Fe, New Mexico, he was out there to kill it. He knew in advance what the answer was going to be. Why study it when you know the answer already? Someone told me an anecdote. I wasn't in there. He came up to the cafe, took an Alka-Seltzer out, threw it into a glass of water, and said, "Gentlemen, I give you cold fusion." That's his attitude toward cold fusion. And he went for the jugular vein. He accused Bacchus of tritium adulteration and this, that, and the other. Here's Close's book, Too Hot to Handle, The Race for Cold Fusion. It was republished by Princeton University Press, I believe, appropriately enough. This is the publishing fiasco of the century by Huizenga, who belittles. I love this. Isn't this great? 1 watt in, 4 watts out. The next version of this book, perhaps he'll put 1 watt in, 1,000 watts out. And it's a fine example of how not to do science. He was the head of the committee. It was his responsibility. He abdicated it. He should be, here he is, he should be hauled before the Congress and called to task on why he was paid as consultant to do this, when in advance of being hired, he said, don't have a panel because it's so stupid, it's going to go away. Don't even waste your time. Then when it didn't go away, of course he came in and did his civic duty for the cause of science, and we got what we got. This man was almost a hero. He's hiding out. He threatened to resign from the panel. He was the co-chairman. He had just won the Nobel Prize in '89. He didn't want to muddy the waters. But he didn't also want his name on this report. He could see the report was going in a bad way, that it was concluding negatively when it shouldn't have. He threatened to resign. Huizenga wouldn't tolerate that. He gave him a reason to stay, gave him a preamble, a little loophole. He wanted complete death, but he got only partial death, that is Huizenga. Ramsey continues to be interested in cold fusion. Can you imagine? This guy, Ramsey, Nobel laureate of Harvard, he asked Julian Schwinger, who was very interested. Julian Schwinger's dead. Schwinger, in his last days, told me that Ramsey would ask him periodically, "Hey, Julian, what's going on with cold fusion?" So he's interested in it, but what is he doing? Nothing. No civic responsibility. Julian Schwinger said, "Does cold fusion have a future?" Forgot about that. I have little hope for it in Europe and the United States and the West. It is to the East, and especially to Japan, that I turned. 1990. It was around December 7th, by the way. I predicted that the U.S. might catch up, and probably will, because of the entrepreneurial spirit. only because of the entrepreneurial spirit. Japan, in its very methodical, highly structured way, is doing the old stuff. Of course, when they find out about this SETI experiment, they're going to go ballistic. They are going to go absolutely ape. They will be making this in new forms, and they'll be putting it in cars faster than you can say Jack Sprat. They know how to measure power. Teller, where the heck is he? Nowhere. Okay, except on October 16th or so, 1989, there was a closed-door meeting in Washington, proceedings still not published, NSF-EPRI meeting, positive results. He came out and even said some positive things, but the whole thing got forgotten. Here's Maddox of Nature, another guy very responsible for why this whole thing was badly treated. He said, I think, broadly speaking, it's dead and it will remain dead for a long, long time. I suspect he thought it would rise, and of course it has. And now he's no longer the editor of Nature, so he's, at least in his retirement, he'll have some fun. This was in October of '92 during the conference in Nagoya, Japan. Look at the title, Cold Fusion Produces Heat But No Papers. NTT researchers have no paper published or submitted to back up their claim. The company's public relations department could not even provide an abstract. What horse manure? There were abstracts all over the place. There was a paper. And here's our friend, our little smart friend, Steve Koonin of Caltech, who proved that cold fusion couldn't exist based on certain calculations of fusion probability cross-sections and so forth. He said, we're suffering from the incompetence and delusion of Drs. Pons and Fleischmann. He said that at that May meeting, the public hanging in Baltimore. The other thing about him is he said, another famous statement quoted in Fire from Ice, if pigs had wings, they could fly, but pigs don't have wings, and they can't fly. Well, Dr. Storms provided this modest art at the recent meeting. The flying pig does exist. We should have a flying pig award, he says. Hazenga here. Pigs can't fly because theory proves they do not have wings. Taubes, if this is a flying pig, my book will fail. Morrison, a really wacko physicist from CERN, who has racial theories, believe it or not, racial theories of the distribution of cold fusion results. Northern European countries did not get positive results, whereas southern countries along the Mediterranean and even the southern part of the U.S. got some positive results. And in the backwoods, outside the influence of the New York Times, he said this on national television, by the way, on a NOVA program, and he still goes on, and he'll go to his grave, I'm convinced, and I hope he does, convinced that cold fusion doesn't exist, because 3 out of 4 countries and 66% of pig owners do not have flying pigs. And Jones, who's a terrible man, he got the thing all off onto a bad start to begin with. Many reasons Jones has problems. Not the most important of which is he doesn't believe in measurements. He says he does, but he doesn't really. He's got something in for Pons and Fleischmann. There was bad blood, but he's not big enough to say, okay, now I agree the excess heat is real. Whatever it is, it's real. It can't be explained chemically. He's always volunteering. Oh, come to BYU, and I'll test out. He said this to SETI recently on the net. He said, come to BYU, and we'll test it out with our neutron meters and detectors, and we'll show where the nuclear products are. What he's out to do is to prove that if the nuclear products don't exist, then the heat doesn't exist. That's what he's out to prove. Good luck, Steve. In any event, this is what he said about cold fusion. Why are the people of every culture so anxiously embracing claptrap that should have been left behind? Part of the reason to be found in the uncritical acceptance and promotion of these notions by the media, prominent personalities, and government agencies. I don't see them promoting cold fusion, by the way. The cold fusion farce, this was in the same statement, should have been tossed into the trash heap long ago, but justifiable fear of legal actions by offended supporters has stifled opponents. I have never met James Randi coming to a cold fusion meeting. I've never known that he's cited the technical literature, but he is a magician, so he can do magic. At the risk of being unbearably realistic, I must tell you that Elvis Presley is dead. really dead. The sky is not falling. Perpetual motion is a chimera. Cold fusion is a dead duck. The Earth is not flat, and the fault lies not in our stars, but in ourselves. And we're almost done with the slides, and then we'll go right on to this exciting tape. Bacchus, who was attacked for alchemy. Here's the Titanic. This is what's happening now to the opponents of cold fusion. They're going down. They're having some last-minute parties on the deck, but soon they will be taken care of in a big reservoir of fusion fuel. Okay, Jerry Bishop. Where's Jerry? I don't know. He wrote many articles. He's the best guy outside of yours truly covering cold fusion, but he did it nationally and was severely criticized. He won a Science Journalism Award. The physicists didn't want him to get the award. They held a conference. This was the American Physical Society. If you read Fire from Ice, you'll hear that episode. They gave it grudgingly, and they told him, don't write about cold fusion anymore, Jerry. So I guess he obeyed. He hasn't written anything since July 14th, 1994. Huh?
Must have paid him well not to write.
No, he's not payable, but he has an editor who's giving him a problem. This was in 91, November. Look at this. This guy who's not covering cold fusion at all, who thinks it's nonsense, Broad, writes, every time there's a breakthrough at Princeton here, big news, knee-jerk reaction, breakthrough, 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 but never any breakthrough in cold fusion because cold fusion is nonsense. Okay? Dyson said it the best. This is the essence of what's going to happen. There is no reason why a new technology has to develop like fission and hot fusion on a 30-year time scale. All it needs in order to go fast is small-size units, simple design, mass production, and a big market. He said that before the cold fusion era. Now we have it. It's sitting on a table. It's ready to go, and nothing will stop it. The knowledge is out there. God forbid if the mafia or the tokamak, whatever, got to them at SETI and blew up their lab or something. Everyone knows this now. All we have to do now, tinker is forever, now that it's all published and known about on the nets and what have you, just go to your basement, start cooking up beads, and eventually you'll get the reaction, you know? How many ways are there to code beads? George Miley and his graduate students did it with ordinary nickel. Maybe they put copper on first, I don't know. Whatever, they got the heat. They got a little less intense reaction, but it started faster. By the way, that SETI demonstration, you have to start it with a heater. It has some heaters in it, thermal heaters, resistance heaters, 50 to 100 watts, just to get it going. Heat the water up. It's got a positive temperature coefficient, which means it gets better and better as it gets hotter. I predicted these things. Let's see how closely I came out. I predicted these things back in June of '94 at the SSE meetings, Society for Scientific Exploration, prototype demo units in the next 6 to 12 months. Pretty close, because that was that was after ICCF5. There was a demonstration unit there. I was a little off. Home heating units, prototype, pretty much, yep. It's not an actual home heating unit, but it's pretty close. Make 10 of them, put them in your basement, and your home is heated for a fraction of the cost of a light bulb. Electric generator by December '96, 100, I'm way off there. It's going to happen much sooner than that. By the way, they've generated electricity already. They haven't publicly announced it. The British Channel 4 will have an hour documentary that will make its way, we believe, over the sea. It will be broadcast on December 17th. It will show a small CT cell with thermoelectrics attached, running an small electric motor with a fan. So they have generated electricity already. Massive crow eating will occur. Don't know when that fest will be. We'll send out the crow, invest in crow. The messengers will be blamed, yes. Era of excuses begins and the attempt to rewrite history. It's already in process, but we won't let it happen because it's all on videotape, electronic mail, etc. Cold fusion-powered car prototype by 2000, radically off. Much sooner than that. The prototype, I imagine, will occur in 1996. A small vehicle of some sort, probably Dennis Cravens will do this. He's certainly working on it. A nice hot little baby that will run across the whole United States on nothing but water. And there will be TV crews following at that time, and I'm sure that will make a big splash. Let's look forward to that maybe next summer, let's say. Maybe it'll take a little longer. Who knows? In theory, if you had a crack team right now saying, we've got to make a car in 1 month, I bet you could do it. Merrimack will die. Probably, well, it's dying now. It's down to 240 million from 320. 96, certainly. Oil company stocks will plunge to unheard of lows after these prototypes. That can occur at any minute now. It's very unpredictable. When the big company announces, maybe after that, I don't know. Financial chaos will occur. It's good to have a little chaos every once in a while. Electric power grid begins to wither after home electric generators are introduced. Gradual end of all fossil fuel combustion. And phase out of fission nuclear power. 2 new books by me. Fire from Ice, or something like that. The Dawn of the Cold Fusion Age. Why MIT Slept. And that's it. Now we will go into the most shocking of all anomalies. Something that was brought, I will pass out the transcript of this actual TV broadcast that occurred in Japan on October 1993. I'm not sure this is correct, but if it is not correct, it is a terrible practical joke. Unfortunately, there's evidence, or fortunately, there's evidence indicating that it is by no, yeah, hand them out. It is by no means, it looks like it is by no means a practical joke, because one of the people on this film, Dr. Kawai, note where Kawai is on the film, so that you see, they have now got a United States patent. If you look at the latest issue of, you will see the patent. There's much more on that coming. This is the ultimate heresy that makes even cold fusion look pale in comparison. Let's see it anyway. And again, I'm not sure I believe this, but I'm increasingly of the opinion that it may be true. Because there are too many people getting this. It feels just like, to me, just like cold fusion felt in the beginning. This is insane and madness. It's just that if you keep following it, eventually the proof comes out. But we just have to be scientists about it, not politicians. All right, this is in Japanese, which I think is better because it really gives you the effect of the reality of it when you hear it in Japanese. And you can go back and read it. This was translated by a highly competent